All right, so in this lesson, we're going to take a look at a different form of a parabola in terms of its equation. Okay, vertex form is the one that we've been looking at so far, and it's, that one that we've been using quite a bit. So y equals a x minus p squared plus q. Okay, it's the one that's easiest to. First of all, you can find the vertex just by looking at it. You know that it opens up because a is positive or negative, right? That tells you whether the parabola opens up or down, and it tells you if things have been stretched. Okay, so there's lots you can tell from vertex form. Standard form is just another way that we can leave the equation that honestly isn't as useful. We're just going to look at what it is. Okay, so we're going to start out with vertex form of the parabola, which is y is equal to vertical stretch of the scale factor 3, x minus 5. So 5 is the x coordinate of the vertex, and 60 is the y, negative 60 is the y coordinate. Okay, so what we're going to do to get standard form is just simplify this thing. So in other words, we are going to take the x minus 5, which is being squared, and we're going to FOIL that out. All right, so we're going to do this part of it. All right, so FOILing that out is going to give us, okay, x times x is x squared, minus 5x gives us negative 10x, and negative 5 times negative 5 is positive 25. So when we FOIL that all out, we get the trinomial x squared minus 10x plus 25 minus 60. Okay, so looking at that a little bit more, the reason I use those big red square brackets there is because 3 is multiplying that whole deal. So when I FOIL it all out, I have to remember now when I remove the brackets, I have to remember to distribute 3 that is owed to each of them. Okay, because the whole thing's multiplied by 3. So we get y is equal to 3x squared. 3 times 10 is 30. And 3 times positive 25 is 75. So I don't have to write the brackets anymore because I've given everybody their 3 minus 60. All right, so there's a little simplifying there that we can do at the end. And we get 3x squared minus 30x plus 15. Okay, so we've simplified this into a trinomial just as we've done really since the beginning of the year. And this form is called the standard form of the parabola. Okay, so let me just draw some shapes around there. So we have vertex form up here, and we have standard form down here. Okay, so let's take a look at standard form for a second. Notice the standard form is kind of makes you think of last year when you were dealing with trinomials, where it's y is equal to some coefficient, which we're going to call a, x squared, plus some number there. In this case, it's negative 30, plus c. Okay, so it's always in that sort of trinomial thing where it's like an x squared term, an x term, and then the constant at the end. So in this particular triangle, the first coefficient, a, would be 3. B would be, well, notice it's plus some number. Well, the number that would have to be added to look like subtracting 30 would be negative 30. And C would be positive 15. Okay? But that's generally what standard form is. Now, is that useful for much? Not a whole lot when it comes time to graphing. Okay? There is one thing that it's useful for, which I will get to in a moment. Okay, so we're going to do one last example, putting something in the standard form. Okay, y is equal to 1/2 x plus 1 squared minus 7. Okay, so we're going to start by FOILing out x plus 1 times itself. minus 7. Okay, so we're going to FOIL all this out, and that is going to give us, I like to keep different colored brackets there just to sort of just to show the area that I'm working in. So then that's x squared, and then the outside is 1x, the inside is 1x, so it's plus 2x, and then the last is 1 times 1 is 1 minus 7. And then y is equal to, now if we distribute the half, we're going to get 1/2 x squared. Then 1/2 times 2 is 1 x. 1/2 times 1 is 1/2 minus 7. And then simplifying the end, I'm going to get y is equal to 1/2 x squared plus 1x. I'm not going to write the 1 this time. And then the last two constants at the end, 1/2 and negative 7, give us minus, okay, let's see here. So 1/2 minus 7 over 1. Well, it's negative 6.5, but let's do it by changing them both to improper fractions. So 1/2 minus 7 over 1 would be 1/2 minus, in order to have common denominators, I need to multiply this one top and bottom by 2. So that's 14 over 2. So that would give us negative 13 over 2. So minus 13 over 2. So there's the standard form of this parabola. Again, not totally useful, and to be honest, not something that you're going to be doing that much, but I just want to show you kind of how to go from vertex form to standard form. Okay. Most of our time is honestly going to be spent doing the opposite of what we just did. That is, starting from standard form and putting it into vertex form so that we can graph it and find the vertex and all that stuff. Okay, the last thing that I want to point out here is here's an equation that happens to be in standard form. It's like that regular simplified trinomial. And this is about the only thing that it's useful for us this year is what's the y-intercept? Well, how do we find the y-intercept? Well, since the y-intercept is a point that's somewhere on the y-axis, all we know about it is that its x-coordinate is 0, and we don't know its y-coordinate. If we did, that's the y-intercept. Well, this is just a reminder that when you're looking for the y-intercept, you want to make x equal 0 because that's for sure true about the y-intercept. So when we do that, notice what happens. When I make x 0, I plug it into the first part. I plug it into the second term. And because it's 0, well, 4 times 0 squared, well, 0 times 0 is 0, and 4 times 0 is 0. 5 times 0 is 0. So basically, those parts just cancel out, and we're left with the end. Okay? So that's the y-intercept. All right, so what does this tell us? Well, this tells us that if we have something in standard form, that end constant is the y-intercept. Okay? So that's kind of really all it's super duper handy for. We are going to spend the rest of the time kind of working on going the other direction.